So guys, welcome back again. Current electricity, the shocking chapter. Riju and PSK classes. We have stopped in the previous section with this question on the board. What was given? A steady current flows in a metallic conductor of non-uniform cross section. Which of these quantities is constant along the conductor? Current, current density, electric field, drift speed. Okay. So before I answer, this is a diagram. This is a long wire. I am taking a section of that one. So this wire, this looks like the diagram of Bernoulli's principal derivation, doesn't it? Okay. So this is not a pipe, it's a wire. This side has got a cross section A1, this side has got a cross section A2. Then what factor remain? There is a steady current, they give you a steady current. So current is constant, current is given as steady. See the question, in the question it is steady current. Write this equation, I equal to NA into VD into E. Identify the constants in these equations. It is given that current is constant. So this is given as constant. What is N? N is the number density of electrons, and the number density of electron depends on the nature of the material. Copper will have a high number of density of electron, but plastic will have a low number density of electron. So this is a feature of the material. So if it is same material here and there, same material, then N is again constant. Okay. Now why this is constant? Because this is given in the question. It's given. And why is this constant? Because it is the nature of material. Now, what is E? Charge of the electron. This is constant. Whatever be the material, whatever be the condition, charge of the electron is always constant. Then what does it mean? That means when I, N, E are all constant, I can rewrite it like this. See, if I write I equal to N A V D into E, I will club all constants on one side. So what will I get? I can say A V D equal to I divided by N into E, and this is a constant. That's a constant. So A into V D is a constant. Okay. So what does it mean? The drift velocity is inversely proportional to area. So during the motion of the electron, current is in this direction, current is in this direction, this is the direction of current, drift velocity will be in the opposite direction. This is the direction of the drift velocity. Where will be electron faster? Faster drifting. Inversely proportional to area, smaller area, higher speed. That's it. This is exactly the concept given from equation of continuity last year. If a pipe has got smaller area of cross section, the speed of flow will be more. You can apply that one. A1 V1 equal to, I can write A1 V1 equal to A2 V2, where V1 and V2 are the drift velocity at the 2 points. So this is applicable here. So we know drift velocity is not a constant, it varies. Alright. Now there is something about a current density. Again I am taking the same equation, I equal to N into A into VD into E. Fine. So what is I by A? I by A is current density, and that current density is given by N into VD into E. Okay. Now we know that current is constant throughout, area is not constant. So we can say J is inversely proportional to area, because it is given that I is constant. Only when I is constant, current density is inversely proportional to area. So if I say J1 and J2 current densities, the current density will be more in smaller area. So we can say J1 will be greater than J2 current density. Fine. Now electric field. There is an equation which we will derive later, which will actually give you the idea of electric field directly, but here I am taking a different method. We know drift velocity is given by, what was it given by? Speed, magnitude of that one, E into E by M into tau. Now I will tell you, this E is a constant, mass of electron is a constant. Okay. So this tau, relaxation time, is again depends on the temperature, and that is also same. So, we will see that drift velocity is directly proportional to the electric field. Okay. So, through that one you can answer about the electric field also. Later I will give you a direct equation to understand what is the relation between drift velocity, electric field and the conductor. Okay. So, that is how you answer this question. Fine. So, coming back to the question, I will say other than current everything will change. Other than current, only current will remain same, everything else will change. Fine. In 10th standard you studied about Ohm's law, and you know Ohm's law says that electric current and potential difference are directly proportional to each other. Okay. So, the same statement, there is no difference in the statement. It says that the electric current flowing through a conductor is directly proportional to the potential difference across the ends of the conductor, provided that physical conditions like temperature, strain, etc. are kept constant. Maybe in 10th standard you did not have the term strain, you had only temperature. Okay. So, this is Ohm's law. You do not have to use the term strain to get full mark. Okay. Simply say temperature is constant, that is sufficient. But if you do not mention the condition of temperature, then this law is not correct. So, what is Ohm's law? Electric current through a conductor is directly proportional to the potential difference across the two ends. That is the idea. Now, if you have a conductor, here, okay, and this side has got a potential V1, this side has got a potential V2, then the difference in potential is V1 minus V2. It is just like a difference in the height, H1 minus H2. This is what we write as V. Do not worry, later these things will become clear. Now, there will be a current from higher potential to lower potential. There is a current higher to lower potential. Then this current is directly proportional to the potential difference. That is the condition of Ohm's law. Now, we normally write this in the reverse manner. V proportional to I, and we take the ratio V by I, and we know this ratio is called resistance of the conductor. So, V equal to Ri, where the constant of proportionality is known as resistance of the conductor, all from 10th standard. SI unit of resistance, you know, it is ohm, and it is the symbol you already know, ohm. Okay. And we also know that resistance of a conductor depends on many factors, such as it depends on the length, area of cross section, it depends on the material, and it also depends on the temperature. Okay. So, that is Ohm's law. Now, you also studied a graph of current and voltage like this. Be careful. Normally, potential difference, which is also known as voltage, is taken on this axis and current is taken on the other axis. You can do the reverse also, no problem. If it is given like this, the slope will give you resistance. Slope calculation. You studied slope calculation in many areas, so no need to tell you. Okay. Slope calculation, you consider triangle, this will be equal to delta V, this will be equal to delta I, and this equal to theta. So, the slope can be calculated like delta V by delta I, which is equal to V2 minus V1 divided by I2 minus I1. This gives you the slope. This is resistance. If you want slope at a particular point here, at a point, then you know this is slope between 2 points. If you want slope at a particular point, then you get it as dV by di. This is also equal to R. The slope of the line gives you resistance. Okay. Now, if it is so, answer this question. Answer in the comment box. Answer this question. See, this is voltage axis, this is the current axis, slope is resistance. So, which line has got more slope? It has got more resistance. We can see A has got a higher slope, so it has got a higher resistance. But sometimes examination, they will try to fool you. Now, which one has got more resistance? Now, the axis got changed, switched. This is current, this is voltage. So, the slope is reciprocal of resistance. You might have studied conductance, which has got more resistance. This time B will have more resistance. There is a shortcut. The line which is closer to the voltage axis will always have more resistance. That is easy. Okay. Now, there is a proof for Ohm's law which you did not study in your 10th grade. The proof is based on the microscopic properties like drift velocity, electric field, etc. This proof is very important. Okay. Same thing, we start from the same thing. You have a conductor, cross sectional area A, number of electrons per unit volume is n, the drift velocity is given, electric field is given, current, voltage, everything is given, and do not get confused because in my graphics I did not notice one point that this is current I and this is the length of the conductor L. Okay. Now, in the last class I taught you that the potential difference divided by length of the conductor. Okay, I think I should start like this. The electric field created is equal to ratio of potential difference and length, that we already know. Okay, and we also know that drift velocity of the electron is given by E into E by m into tau. Let us substitute for V. So, drift velocity is equal to E by m into tau into electric field is V divided by L. We have an equation for current I, and that current I is nothing but N A into V D into E. Substitute from the previous step, you get N into A into, for drift velocity substitute, that is E divided by m into tau into V by L into E. This is the current I equal to, now you can see there is an E here, so you can multiply N, then E square, then you have tau divided by m into V divided by L. I am sorry, I missed one term, there should be A here. Okay, 1 second, let me make some edit here. I forgot about this A, so A will be here, N is here, equal to current, a beautiful relation. Okay. Now, I am going to rearrange this. I am going to rearrange it like I equal to N E square tau by m into A divided by L into V. There is a purpose of writing this in this format. I will tell you why. This has got 3 parts. It has got 3 parts. Which are those 3 parts? One is V. It is applied voltage. V is what? It is applied voltage. The voltage given, applied potential difference. Okay. And what is A and L? A is the cross sectional area, L is the length. Okay. What is N? Number density. E is the charge of the electron, m is mass of electron, tau is the relaxation time. Okay. Now, the important thing is this. Okay, I have 2 pen with me. Assume that these 2 are conductors. The shapes are different. The sizes are different. So, this A and L will depend on the shape and size of the conductor. A and L depends on the shape and size of the conductor. You can take long wire, short wire, thick wire, thin wire. A by L will depend on the conductor. Fine. So I will say this A by L is a constant. When is it a constant? It is a constant for a given conductor. It is constant for a given conductor. I am giving you one conductor, then this A by L ratio is fixed. After that, it will not change, because just because you give a current, the shape will not change. And what about N E square tau by m? This E square is always a constant, charge of electron. M is again a constant, and N depends on the material. I told you before, N depends on the material. So for a given conductor, the material will be fixed. So N will be constant, and the tau, relaxation time, that is the time between collisions, that will depend on temperature, because if temperature increases, speed of the electron will increase and the number of collisions will increase, so the tau will be affected. So if temperature is constant, then tau is also constant. So I will say for a given conductor, I am writing here at a constant temperature. for a given conductor at a constant temperature, I will tell you, for a given conductor, normally I do not use red color, but today I am using red color. For a given conductor, A by L is a constant. E square by m is always a constant. For a given conductor, the material will have n as a constant, and if temperature does not change, tau will also become constant. So, you can see these terms will become a constant under this condition. Then current and voltage are related. How are they related? Then the current is directly proportional to the voltage. This is called Ohm's law. That is why I say when you define Ohm's law, the term constant temperature is important, because without that this cannot be proportional. Fine. So, these are the steps of the derivation. You can see that in the next slide here. I derived the same thing. Okay. We get I equal to n square tau by m into A by L. This is L into V. For a given material at a fixed temperature, n square tau by m is a constant. For a given shape of conductor, A by L is constant. Therefore, for a given conductor at a given temperature, n square tau by m into A by L remains constant, and current is directly proportional to potential difference. So, that is the definition, that is the proof of Ohm's law. So, the ratio of the potential difference to current become a constant. So, we can say from this equation we can write V by I. Okay. From this equation I will write a V, I will write a V by I. V, the voltage given, I, the current produced, equal to V by I equal to, that is like a m divided by n e square tau into L divided by A. And this is what we call as R, the resistance of the conductor. So, from this derivation I am getting an equation for resistance as m by n e square tau into L by A. You remember, you studied this, resistance of a conductor depends on length, area and the material and temperature. So, length is here, area is here, material and temperature means number density depends on the material, temperature, relaxation time. Fine. So, this term m by n e square tau is called rho, then we write the equation as rho into L by A, R equal to rho into L by A, where this rho is called resistivity of the material. Rho is called resistivity, is given here. Rho, the resistance of the conductor is R, m by n e square tau, m by n e square tau is called the resistivity of the material. So, this is an equation for resistance of the conductor. So, you can get a question like this one, define and prove Ohm's law and get an equation for resistance in terms of the microscopic parameters. So, you can write a resistance in terms of all these things. Fine. So, that is again must be easy for you, no complex concept in that one. Okay. But this Ohm's law is not always valid. This is a board examination theory question that you can expect given in the NCERT textbook. What are the limitations of Ohm's law? There are 3 limitations for Ohm's law. First one, Ohm's law is not applicable when voltage ceases to be proportional to current, because according to Ohm's law, voltage current graph must be straight line. In certain materials, when the voltage increases, the proportionality changes. You will not get a straight line. That is why when the voltage ceases means stops. Here you can see up to this point it is almost a straight line. Beyond that it stopped to becoming proportional. Beyond this you can't apply Ohm's law. That is one case. Okay. Second case, in certain materials like in semiconductors, you will get a VI graph like this, voltage current graph. You won't get a straight line. For positive voltages you will get one type of current, for negative voltage you get another type of current. There is a device called diode, semiconductor diode, which will conduct only in one direction, not in the other direction. So, in all these cases you get graphs like this. Here you can say the relation between V and I depends on the sign of V. Sign of V means whether it is positive. For positive one relation, negative one relation, in such cases Ohm's law is not applicable. Fine. There is one more case to go. V and I, see the relation between V and I is not unique. Not unique in the sense, see here, see here, voltage taken x axis, current taken on y axis. For two different voltages, you can see one here and one here, you will get the same current. That's funny. That means maybe for 10 volt you get 2 ampere, after that for 30 volt also you get 2 ampere. In such cases, we will say Ohm's law is not applicable. There is no unique relation, different relations are there for different voltages. But now you can see one more point, here voltage is increasing. Up to this point voltage is increasing, correspondingly there is an increase in current. So, from O to the point A, there is an increase in voltage and there is an increase in the current. But beyond A, suppose A to B here, voltage is increasing but current is decreasing. In such cases, you say this has got a negative resistance region. This has come in many entrance examination. Which region has negative resistance? Okay, so this should be clear. If you see your compendium, I think this question is there. Say from O to A, B, C. Which region has got a negative resistance? You can say it is the region AB. What is the reason? Reason, increase in voltage does not produce increase in current. Increase in voltage produces a decrease in the current. So, that has a negative resistance region, NCERT textbook. And see, up to this point you can say approximately it is a straight line. Ohm's law is applicable. Beyond that it is not applicable. Okay. Semiconductor devices, this is called gallium arsenide. Refer textbook. Gallium arsenide is an example. It's a semiconductor device, a semiconductor material. Fine. So, that's about the limitation of Ohm's law. Those materials which will not obey Ohm's law, where V and I are not directly proportional, are called non-ohmic resistors. Ohmic and non-ohmic. Ohmic means it will obey Ohm's law, non-ohmic means it will not obey. And the reasons, the VI graph may not be linear, you won't get a straight line graph. VI graph may not pass through the origin. That means for voltage 0, current must be 0. In the case of what you call photoelectric effect, you studied a graph where voltage is 0 but current is not 0. Then this is thing, it may conduct poorly or not at all when the potential difference is reversed. When you reverse the voltage, it may not conduct, sometimes it will conduct in a different way. You have two graphs here. One is for ohmic conductor, a straight line passing through origin. Second one, non-ohmic, it's a curved one. It does not obey Ohm's law, non-ohmic conductor. Fine. These things can come in 1 mark questions and it can be asked in objective examinations, like which follows, which is a non-ohmic conductor according to the graph given. Okay. Now one more derivation to go. One more derivation to go is the relation between current density and electric field. Very important. This is also known as Ohm's law in the vector form. Current density and electric field. It's pretty easy because we have done part of this in the previous section. Okay. We have these steps. Consider a conductor, same conductor, length L, area A. This is length L, area A, voltage is V, and we derived that. We derived earlier that the current flowing through is given by N E square tau by M into E. I think it should start from the basic level. We know I is equal to N A V D into E. Now we also know that drift velocity is nothing but E into E divided by M into tau. Earlier we substituted for E equal to V by L, but this time we will not do that. We will take E as it is. Then we will substitute back at I, then we will get I equal to N into A into, for VD we will substitute E into E by M into tau, then again you have E. Fine. So this will give you N here, E into E square, then the tau by M, which is constant for a given material at a given temperature, okay, into A into E. This is I. Fine. Now from that from that we can write current density J equal to I by A. J equal to I by A, and that is given by, it is given by N E square tau by M into E. N E square tau by M E. Okay. So we have J equal to, what is N E square tau by M? Earlier I told you that M by N E square tau as rho, the resistivity, but this is a reciprocal of resistivity, 1 by rho, reciprocal of resistivity, it is written as sigma, it is called conductivity. So this is conductivity, so we will write like a sigma into E. In the vector notation we write J equal to sigma into E. This is the microscopic form of Ohm's law. V by I equal to R is a macroscopic form, because V and I are for large objects, but this J and E can be defined at a particular point in a conductor. So call it as microscopic, the other one as macroscopic. Like V equal to I into R is a scalar macroscopic form, J equal to sigma is the microscopic vector form of Ohm's law. Fine. So these are given in the different steps. You have to go through this one. This equation should be studied very clearly. I think in one of the NINT examination, in one question they asked about this thing. Okay. So dear students, some amount of complex derivation part is over. Okay. Now what we have to study is the property, something like that. So this part you should see the derivation of drift velocity, the proof of Ohm's law, drift velocity, Ohm's law in the vector form. Please study this derivation by writing, because these are important for your board examination, especially the limitation of Ohm's law, those graphs, these are very important. Okay. So hope you will study all these in time, and do not keep this for tomorrow. Be up to date and updated always. Thank you for your time. See you in the next class.